In the vast cosmos, our solar system sometimes gets a rare visitor from another star. That's what 3I/Atlas is, a true interstellar object, discovered in 2019 by the Atlas survey in Hawaii. The I stands for interstellar, meaning it came from beyond our sun's reach. These objects are cosmic messengers, carrying clues about planetary systems far from our own. Unlike distant stars we only see through telescopes, 3I/Atlas brought a physical sample from another part of the galaxy right to us. Studying it is like getting a rock from another world, direct evidence of how other systems form. When first spotted, 3I/Atlas was a faint smudge, quickly developing a coma as it neared the sun, hinting at a mix of ice and rock. But its speed and trajectory proved it wasn't local, it was just passing through, a cosmic tourist. These visitors are time capsules from other stellar nurseries. By analyzing their size and makeup we can piece together a universal story of planet formation. 3I/Atlas, only the second confirmed interstellar object at the time, promised answers to big questions. But to unlock those secrets we needed our most powerful eye in the sky. Enter the James Webb Space Telescope. The James Webb Space Telescope, or JWST, is humanity's most powerful space observatory. Unlike Hubble, which sees mostly visible and ultraviolet light, Webb is designed for infrared, letting it peer through cosmic dust and see the hidden universe. Its giant gold-coated mirror collects faint, ancient light from the edge of the observable universe. To work, Webb must stay incredibly cold, shielded from the sun by a tennis court-sized sun shield. Webb orbits at the second Lagrange point, 1.5 million kilometers from Earth, where it has a stable, unobstructed view of space. This unique vantage point allows Webb to observe faint, distant objects like 3I/Atlas with unprecedented clarity. Its infrared vision is like superpower goggles revealing what's hidden behind cosmic fog. With this technology, astronomers could finally get a clear look at our interstellar visitor. Webb's capabilities made it the perfect tool to study 3I/Atlas. For the first time, we could see details that were impossible before. The stage was set for a breakthrough. Measuring the size of a distant faint object like 3I/Atlas is a huge challenge. From Earth, it's just a point of light, often obscured by a coma, a cloud of gas and dust. It's like trying to spot a bee inside a cotton ball. Scientists usually estimate size by brightness, but that depends on both size and reflectivity or albedo. A small shiny object can look as bright as a large dark one. Early estimates, based on ground and Hubble observations, suggested 3I/Atlas could be 20 to 50 kilometers wide, a giant among comets. But these were just guesses, muddied by the coma and the object's faintness. Subtracting the coma's light was imprecise, leaving a wide range of possible sizes. To solve the mystery, astronomers needed a telescope that could see the heat signature of the nucleus itself. Only then could they distinguish the bee from the cotton ball. The answer would require Webb's unique infrared vision. The world waited for a definitive measurement. The moment of truth was coming. Webb's infrared power changed everything. Instead of just reflected sunlight, Webb measured the heat radiating from 3I/Atlas's nucleus. This thermal signature gave a direct, reliable way to calculate its size, regardless of surface reflectivity. Webb's instruments separated the heat from the coma and the nucleus, isolating the true core. It was like finding a warm stone hidden in cool dust. The data revealed the nucleus was just 4.8 kilometers, about 3 miles across. This was a precise, direct measurement, ending years of guesswork. The result was a triumph for Webb and the astronomers who chased this cosmic ghost. The era of uncertainty was over. We now knew the true size of this interstellar messenger. This new number would reshape our understanding of 3I/Atlas. Webb had delivered clarity where others saw only mystery. The universe had given up one of its secrets. Webb's measurement shattered old estimates. Previous guesses put 3I/Atlas at 20 to 50 kilometers wide, like mistaking a small town for a sprawling city. The difference in volume is staggering. The old high-end estimate was over 1,000 times larger than the real size. This dramatic downsizing revealed something crucial. 3I/Atlas isn't big and dark, but small and shiny. Its surface is far more reflective than typical solar system comets. Earlier observers were fooled by its brightness, not realizing its high albedo. Webb's infrared data replaced assumptions with direct evidence. It's like reading a license plate up close instead of guessing from a mile away in the fog. This is scientific progress, better tools, better data, and a more accurate picture. The story of 3I/Atlas's size is a lesson in the scientific method hypotheses tested, revised, and improved. Old ideas gave way to new certainty. This isn't a failure of earlier science, but a triumph of discovery. Each step builds on the last, refining our view of the universe. Webb's breakthrough set a new standard for studying interstellar visitors. Why does size matter so much? In astronomy, it's the key to unlocking a world of information. Knowing 3I/Atlas is 4.8 kilometers wide lets us estimate its mass, density, and composition. Is it a fluffy snowball or a dense rock? Its modest size fits with theories of gradual comet formation, not violent origins. Its high reflectivity suggests a surface covered in fresh ices, possibly untouched since its birth. This means 3I/Atlas could be a pristine relic from the dawn of its home system. The discovery ripples through planetary science, refining models of planet formation and comet composition. It tells us the building blocks of other solar systems might be similar to our own, and it's a warning: don't judge a comet by brightness alone. The universe hides its secrets in the details. Webb's discovery changes how we'll study every interstellar visitor to come. Each new fact reshapes our cosmic story. Webb didn't just measure size, it revealed what 3I/Atlas is made of. Using infrared spectroscopy, Webb detected water vapor in the coma, confirming it's an icy body like our own comets. But it also found abundant carbon dioxide, a key clue to its origins. The ratio of CO2 to water acts as a cosmic thermometer, hinting at the temperature and chemistry of its birth region. The high CO2 content suggests its home system had plenty of carbon and oxygen in its icy zones. This supports the idea that the ingredients for life, water and carbon compounds, are common across the galaxy. Combined with its small, shiny, pristine nature, we see 3I/Atlas as a CO2-rich snowball from another star. Each detail transforms it from a mysterious point of light into a tangible relic with a story. Webb's analysis gives us a window into the chemistry of other worlds. 3I/Atlas is more than a rock. It's a messenger from the galaxy's distant past. Every new discovery brings us closer to understanding our place in the cosmos. The universe is more connected than we ever imagined. Studying 3I/Atlas is about more than one object. It's about our place in the universe. Its similarity to our own comets suggests the processes that built our solar system are common. This means our story is part of a universal saga. Comets may have delivered water and organics to early Earth. If interstellar comets are common, life's building blocks could travel between stars. The idea of panspermia, life's ingredients spreading across the galaxy, becomes a little more plausible. 3I/Atlas now serves as a benchmark for future interstellar visitors. As new survey telescopes come online, we'll find more of these cosmic messengers. By building a catalog, we'll learn how diverse these objects are and what that means for planet formation everywhere. Each new discovery refines the grand narrative of cosmic creation. For the first time, we're seeing a piece of another star system's history. It's like finding an artifact from a lost civilization, showing what's the same, what's different, and enriching our understanding of the cosmos. 3I/Atlas is a window into the galaxy's past and our shared origins. Webb answered the big question of 3I/Atlas's size, but new mysteries remain. Where did it come from? Tracing its path is nearly impossible after millions of years in the galaxy. Why is its surface so pristine? Maybe it's constantly sandblasted by interstellar dust, exposing fresh ice, or perhaps it traveled through a particularly empty region. What else is in its makeup? Webb found water and CO2, but are there complex organics, the building blocks of life? Detecting these faint signatures pushes even Webb to its limits, but future observations may reveal more. As 3I/Atlas speeds away, it grows fainter, soon beyond even Webb's reach. But the data we've gathered will fuel research for years. Scientists will keep analyzing, modeling, and learning from this cosmic visitor, and will watch the skies for the next interstellar object. Each new arrival brings fresh secrets and new questions. With Webb and future telescopes, we're ready for the next chapter. The universe always has more to reveal.